be here after school.
All right, so number one, well, actually 4, 5 in general, we learned about 2 shortcuts to proving that triangles are congruent. What are the 2 shortcuts? Good. Side, 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 and side, angle, side. So side, side, side means that you'd have information about all 3 pairs of sides marked as congruent, and side, angle, side would be 2 sides, and then where that side meets on each triangle, or the included angle. So number 1 says show that triangle ABC is congruent to DBC when x is 6. So if these were congruent, what would be true about, and you could do these a couple of different ways, right? If it's ABC, that means AB matches DB. That means BC matches BC, that's the reflexive side. And AC matches CD. So I know that about the sides, and then about the angles, angle A would match angle D. Angle ABC would match angle DBC. And angle ACB would match angle BCD. So knowing that they're all congruent, you would know all that information, okay? This is in the reverse. Like, okay, if I have those side lengths marked as congruent, what could I do with the 3x plus 10 and the 4x plus 4? You can plug in the x and show that they'd be the same, right? Or could you work backwards, set those equal to each other, and show that x would be 6? Would you have gotten x would be 6? Yeah. Okay, and you could have done the same thing with the angle. So there's 3 different ways to show this. One is say that, okay, 26 would equal x plus 20. So if I plug in the 6, I'd get 26 equals 26. So we've just verified the angles would be the same. And then do the same thing with the sides. 3 times 6 plus 10 should equal 4 times 6 plus 4. They're 18.
28.
Thank you. 18 plus 10, which is 28. 24 plus 4, which is 28. And 28 equals 28. So again, we're verifying that those 2 measurements would be the same. Or I could have just solved for the x's and gotten x equals 6 in both the angles or the sides. So your work is your verification on those things. So when it says that show that they are, you're showing it based on your work.
We don't need to do both.
You don't need to do both, yep. All right, which postulate, if any, can be used to prove the triangles are congruent? So if I look at number 2, do I have side, 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 or side, angle, side?
No.
Okay, careful. What do you have? On this side, a side, right? I've got, yeah, 1 side and 2 tick marks on that one. 1 side and 2 tick marks on this one. This is the included angle, but this one's not. So this is no. There's not enough information to prove that those triangles are congruent.
What if they're like both like side? Would you congruent?
If you could do, say that again?
Like if they're both side.
No.
Aren't they reflective?
No, there's a vertical angle, right?
Yeah.
The vertical angle could be marked as congruent, but that's still not the included angle.
But, like if the left angle was on like the bottom.
No. So no. I know it doesn't, it's not why it happens, but if you can spell a bad word with the letters in which you create, so if you're given 1 angle and 2 sides, it's not an option. So even today we're going to learn 3 more options of shortcuts, but angle, side, side is never one of them. So you can't do it with 2 sides and the non-included angle. Technically the 2 triangle, like I could give you 2 pieces of like string, let's say, and told you that you have to arrange them so that where they meet is a specific angle, and then close in your triangle. And if I gave you all the same measurements as I gave Callie, you're going to make the exact same triangle. There's no way to make it 2 different ones. That's why they would be congruent. But if I gave you 2 sides and an angle but said not where they meet, you can make 2 different triangles. Those don't have to be congruent. So side, angle, side works, okay? But angle, side, side, or side, side, angle doesn't. There's no such thing.
How about angle?
Nope. Nope.
There's angle, side.
There is. So you'll learn 3 more today. Okay, so then 3. Do we have enough information to prove that these are congruent?
Yes.
What would it be? Side, side, side. Technically, I don't have 3 sides marked, but what do I know? The reflexive side. Does everybody see that? Yes. So this is the 3rd pair, because if I split those into 2 triangles, that same side goes to both. Okay, so 4 is a proof. Again, we'll try to work through it together, okay? But based on what it says at the top, I'm going to start by drawing on my diagram. It says PN bisects MO, and PN is perpendicular to MO. So I already know it bisects it and meets it at a right angle. So this would be my given, right? That's what's given to you. And what else is given to you? Number 4. So number 2 says MN is congruent to ON. MN is congruent to ON. How is that true? So close. Of a bisector. So what they gave me is that it's the bisector. So it's the definition of a bisector. If it had said, which you'll see sometimes, that N is the midpoint of MO, then that's the definition of a midpoint. But what they gave me this time was the bisector. Number 3 says PN is congruent to PN. What's that? Good. Number 5 says angle PNM and PNO are right angles. How do I know that? These are both right angles. What piece of information did they give you that leads you to that? They're perpendicular. So that's definition of perpendicular. Then it says PNM is equal to PNO. Nope, we're not to the triangles yet. We're on the angles, right? So there's 2 ways to do this one. One would be split it up to say if they are right angles, then they are 90 degrees. So one way I could do it is this. I could say if that's the case, then PNM and PNO equal 90 degrees. And that would be the definition of perpendicular. And then I can say PNM equals PNO, and that would be substitution. So if you had done it that way, it takes 2 steps. But the way this is done is they're going straight from the fact that they're both right angles to 6, which is that they're congruent to each other. So you're missing the step in between. And so for here, we could say that perpendicular lines, which is one of our postulates from this chapter, perpendicular lines form congruent adjacent angles. So again, if you wanted to add that they equal 90, so then equal each other, that would be the definition of perpendicular and then substitution. But if you do it in one step like that, we had postulates and theorems that told us about perpendicular lines back in chapter 3. And one of them said that perpendicular lines form congruent adjacent angles. Now I'm at my proof statement, which is that triangle MNP is congruent to ONP. So we only have 2 shortcuts to prove that triangles are congruent, right? What are they? So which one of them would be in this triangle? Good. Do you know anything about all 3 sides? No, right? What we do know is that we have 2 pairs of congruent sides, those and these, and the congruent angles in between or where they meet. Questions on that? All right, this was your homework from yesterday. So number 1 is neither. Number 2 is side angle side. Number 3 was neither. Number 4 was side, side, side. Number 5, you had to set them equal to each other, and you should have gotten x equals 1.8. Number 6, set them equal to each other, and you should have gotten x is 17. And then the proof could be done different ways, but this is one example of how to do it. So it said C is the midpoint of AD and BE. So obviously that stuff is given. If it's the midpoint, then it means that AC equals CD and BC equals CE. That's the definition of a midpoint. And then 3, and honestly, if you don't have 3, I'm fine with it. If you went straight to that they're congruent, it's fine. You don't have to give me the equal and the congruence. But if it is there, you want to make sure you know the reason. So if I'm going from equals to congruent or congruent to equals, that's the definition of congruence. In this case, definition of congruent segments. And then, so if I zoom in on this one, so you got given that this was congruent to this, and then this was congruent to this based on the midpoint, and then you had vertical angles in there that are congruent, and then you had enough information to say those were congruent for side, angle, side. Questions on the homework?
Number 3.
So number 3, you're given that there's 2 pairs of sides that are congruent, right? This one's congruent to this one, and this one's congruent to this one, but and an angle, but it's not the angle where they meet. It has to be the angle where they meet. So if this angle was marked congruent to this angle, that's side, angle, side, and that would work. But because it's not where they meet, it doesn't work.
I have a question. For the third proof, couldn't it also be like the third step?
Third step.
Couldn't it also be definition of midpoint as well?
Well, the difference is they're going from equals to congruence or congruence to equals. So that's the definition of congruence. And if you didn't have step 3, I would not mark your proof wrong. Like, it's just not a step that is going to change the flow of the proof. But if these steps are here, your reasons need to be that. Okay. Questions before we get into the notes for today? Okay. So 4, 6. Yesterday we learned 2 shortcuts. Today we're going to learn 3 more. So in total you have 5 shortcuts. And they're all acronyms, okay? So we're going to learn about angle, side, angle, angle, side, and hypotenuse leg. When you go to answer like why 2 triangles are congruent and you spell out a bad word, it's not because it's a bad word that it doesn't work, but it doesn't work. Whether that bad word is forwards or backwards. So if you write on your paper ASS, it's wrong, right? And it's not wrong because it's a bad word. It's wrong because those things are not enough information to prove that triangles are congruent. If you write on your paper SSA, it's still not right, okay? There's no such thing as side, side, angle, or angle, side, side to prove that 2 triangles are congruent. There is angle, side, angle, 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 side, hypotenuse leg, side, 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 and side, angle, side. Hypotenuse leg, yeah. All right, so included sides and angles. So we talked about the included angles yesterday, right? Where the 2 sides meet would be your included angle. Now we're talking about included sides. So the included side is the common side. Oh, that's included. Side is the common side of 2 consecutive angles in a polygon. The following postulate that's after this uses the idea of the included side. Say it again. Oh. So if you look at the diagram that's there, I'll get it. If I asked for the included side for angle P and angle Q, it's PQ. It's going to be the segment that connects those 2 angles, okay? The name is actually based on the 2 angles. But you don't always have a name. So again, included side is the segment that connects those 2 angles. So what if I asked you what the included side was of angle P and angle R? What's the side? Nope. Angle P and angle R. PR. Okay. It's actually made up of the letters that are those angles, right? But it's the segment that connects those 2 angles, which would be PR. So here's our next shortcut. And again, remember, I'll go back in a second. So the 451 doesn't mean, it means something. It means chapter 4, 5th section, first one in the section. But the number outside this book means nothing. But angle, side, angle is a postulate that exists in every single geometry book. So that's what I want you to know. I want you to know the name of it. ASA, or angle, side, angle, says that you have 2 angles and the included side of one triangle marked as congruent as 2 angles and the included side of a second triangle. So if you look at this diagram, they gave me that angle A matches angle D, angle C matches angle F, and the side that connects each of those is marked as congruent. That is angle, side, angle, or ASA. And again, just like yesterday's stuff, the order of the letters on the statement is important. So because you said A, B, C, I went the longest side to the shortest side. I have to go in the same order on the other one. Longest side, which is DE, to shortest side, which is EF. Yep.
So basically, it's if a triangle has an angle and then a side. And
Yeah. So if you go like around your your triangle, like clockwise or counterclockwise, like in a circle, it has to be angle, side, angle in sequential order. So you can't skip a side. You can't skip an angle. It has to be the angle, the side immediately next to it or attached to it, and then the angle that's also attached to it on the other side. You're welcome. All right, so this one says determine if you can use angle, side angle to prove the triangles are congruent. Can you? How do you know that? So we've got this angle, we've got this angle, that's one pair, right? We've got this angle and this angle, that's one pair. And then what?
You have the side?
I have this side, the reflexive side, right? Is that the side that connects the two congruent angles? No. These are not congruent. But they're not congruent by ASA. Let's say that, because when we get to the end, you'll understand. Okay. So there's not enough info to prove ASA because it's the non-included side. As soon as you see parallel, you should know you have to reference one of those special angle relationships. So if they're parallel, then alternate interior angles are congruent, alternate exterior angles are congruent, same side interior supplementary, and corresponding are congruent. So if I need the visual, you can easily just extend out these lines and draw yourself your transversal. So what angle relationships do you see in here that you could use? Alternate interior. These and these, right? So this angle is congruent to this angle. Does everybody see that? Yeah. What else do you have?
Exterior.
The exterior would be outside, right? There's no corresponding. The alternate interior on this side would also be congruent, but that takes us outside the figure, so that's not going to help us. So that's all we can get from the parallel lines, but there's something else going on in this diagram that we could use.
what about the K and L?
Same side interior?
Nope.
Vertical?
Nope.
They reflect.
What reflects? The sort of on the right track. What piece of information is in that diagram that has nothing to do with the angles? There's nothing about a bisector.
Oh, the
The reflexive side. Train yourself to look for a reflexive side or a reflexive angle. It happens almost every single time. Or not every single time. Probably half the time. Okay? So there's a reflexive side here, yes? Everybody see that? So now I've got one side and one pair of angles. Is that enough information to prove that these are congruent? Do I have two pairs of angles? No.
Corresponding.
Can't. Corresponding would be here and here. That takes me outside the actual shape. When you have a closed-in figure like that four-sided figure, the only ones you're going to be able to use for congruence is alternate interior. And if you only have one pair of parallel lines, this one transversal, the only angle pair you're going to get is this one.
So you can't use angle side angle.
You cannot. If both pairs of sides were parallel, so if I could turn this so you could see that. Now I could say that this one is congruent to this one, and that would be angle side angle. But both of them are not marked as parallel. One pair of parallel lines, one pair of congruent angles. That's all. On what?
But what you just did, wouldn't that make it side angle side?
No. If I turn it back, right? And I use these parallel lines, and this is my transversal. This is an angle. Now I've got two pairs of angles in one side. 2 A's, 1 S, right? But they didn't give me those second pair parallel. So I don't have enough information to prove that that's angle side angle. I have one pair of angles, not two. All right, next shortcut is angle side. So if I have two angles and the non-included side. So now I have two options with double angles. 2 angles on the included side, 2 angles on the non-included side. Okay? So in this case, you see that G is marked congruent to K. J is congruent to M, angle J and angle M. And then in this case, HL is marked as congruent to LM, the side where they don't meet, okay? The non-included side. So these are two congruent triangles, and my reason here is angle side. So you've got side, angle side, and angle side. So if I was trying to use angle side angle, it would be AC and DE. Everybody understand that? Yes? That would be angle side angle. So I still need 2 angles for angle side, but I want it to be the non-included side. Technically, you have 2 options. One is AB and DF, right? The other is, what else is a non-included side? The bottoms, right? CB and FE.
Angle side, like the one we just did, angle side angle, if that doesn't work, that means this one can't work, right? Because don't you have to have a non-included side?
So if the other one doesn't work,
This can't work.
as long as you have 2 angles, this does work. So if it's not the included, if you have 2 angles and a side marked, let's just say, right? If it's the included side, then it's angle side angle. If it's the non-include, it's angle side. But it still works. 2 angles, 1 side. Still works. It just, the question is, which of the postulates does it use? If it's the included side, so if AC was marked as congruent to DE here, I would have angle side angle. If AB is marked as congruent to DF, then it's angle side. Or if CB was marked as congruent to FE, still angle side. All right, so we'll do it together. It's a proof, yes, but we'll do it together, okay? It says use angle side to prove the triangles are congruent. So you know what you want your last statement to be. So if I mark what's already told to me as congruent, I've got X is congruent to V, Y, Z, W. Is congruent to Y, W, Z. And XY is congruent to VY. So I think the hardest part about this proof is identifying what triangles you're talking about. It says to prove that triangle X, Y, Z is congruent to triangle V, Y, W. Oh, I didn't mark this one. Wait, I'm missing an angle.
So you're saying we have to identify the type of triangle first?
Wait, X is congruent to V. This is what I'm missing. Oops.
Can't you use angle side angle for this?
You'd have to know all, so 2 pairs of sides and 1 included angle.
Can it be X and Y and V?
X and angle X and angle Y? Or you mean side X, Y and Y, V? That's 1 pair of sides. That's 1S.
Oh, because they share a Y?
No, they don't share a Y. So this is 2 separate angles. This angle is separate from this angle.
Wouldn't it be angle side? Oh no, sorry. Angle side because
Well, it's still equal. Side is 1.
He's saying, what? Say that again? They'd still be equal. Yeah.
Wouldn't if you do angle X, Y, and angle Y, V, wouldn't they be equal?
Angle X, Y, Z. Is that what you said? What angle are you talking about? Because you gave 2 letters. You got to give 3 letters. X,
Oh yeah, X, Y, Z.
X, Y, Z.
Would that be equal to W, Y, Z?
How do you know that?
Because
So start with the easy stuff, right? State your given. Start with the easy stuff. 1. And then we know what we want the last statement to be. What do you want your last statement to be? Not angle, but triangle. So I know my end result goal is triangle XYZ is congruent to triangle VYW, the ones that we highlighted. You with me so far? And do we know how we want to prove that? How does it say to prove that? It says angle, angle, side. So we even know the reason for that. We just got to figure out how to get there, all the pieces in between. So what information do I already know about those triangles? Because I do have some stuff already about it that's marked, right? What part of it do you already know? What of that acronym, what of it do you already know? So we've got the sides from the XY and the VY. We already have the S. And then we have angle X is congruent to angle V. So we have an A. All we need to do is prove that one of the other 2 pairs of angles is congruent, and we've done what we need to do. So how can we do that? Why would they give us the information on the inside?
because the 180.
So if I gave these numbers, let's make this easy because the letters sometimes confuse us. Let's say this is 1, 2, and 3, and 4.
Isn't y congruent to y?
But that's only the y that is one angle not shared by a vertex. So if I used y at the top, it's technically split into 3 angles. That's not reflexive. Does that make sense? So what I need to do is, why did they give me information about those bottom angles 2 and 3 if I wasn't going to use it?
Wouldn't all 4 equal like 80 degrees?
Well, in pairs they equal, right?
Yes.
So let's say angle 1 plus angle 2 equals 180, and angle 3 plus angle 4 equals 180. And that's linear pair.
Couldn't it be like the triangle sum theorem?
That gets you the top one. Yeah, so you could do that, but then that gets you the top angle. I don't know if that helps you. We might be able to work around that, yeah, but I think it's going to give you some extra steps. So if 1 and 2 equals 180 and 3 and 4 equals 180, then what?
The reason would be a linear pair, right?
Yep, linear pair postulate, yep. Or linear pair, I think yours is a theorem. What happens if 2 sets of things equal 180?
They're supplementary.
Okay, if 2 pairs of angles are both supplementary, what's true about those 2 pairs of angles? They're equal to each other. So angle 1 plus angle 2 equals angle 3 plus angle 4. And that's substitution. Good. Now what do we know about angle 2 and angle 3? Not 90, but they are. We don't know exact measurement, right? But they're congruent. So can we take away 2 things that are the same measure on both sides? What's that called? Subtraction. So I could say angle 1 is equal to angle 4, and that's subtraction.
Wouldn't angle 2 and 3 be equal angles?
No. 2 and 3 are equal, but the triangle, equal angular would be that the triangle has all 3 congruent angles. We don't know anything about that 3rd angle. So now do I have enough information to prove that my triangles are congruent?
Yes.
Yep, that's my 3rd set of angle, or my 3rd letter, second set of angles. Label everything you can at the beginning, state your given, and then look at the end. If your end result is that two triangles are congruent, you now know 4 ways to figure that out. This one even told you which way to figure it out. So it's angle, side, angle. You already had the pair of sides. You already had the pair of angles. All you needed to prove was that there is one other pair of congruent angles. And think about the fact that they gave us the inside triangle information, and we hadn't used it yet. So they don't typically give you information you haven't used. So both of those angles on the inside were linear pairs with the angles that we were trying to prove is congruent. If they're both 180, that means they equal each other. And then if 2 and 3 are congruent, we can take 2 from the left and 3 from the right by subtracting them and get that 1 equals 4. Yep. Okay, example 4 says use angle, angle, side to prove the triangles are congruent. Given JL bisects KLM and angle K is congruent to angle M. So I'm going to start with that. I'll write my given. JL bisects angle KLM and angle K is congruent to angle M. And that's given. And then it even tells you how you want to prove it. So the last step I know is going to be triangle JKL is congruent to triangle JML. And I know that the reason should be angle, angle, side. So based on what I'm given already, I already know there's 1 pairs of angles. And then hopefully from the picture, you remember to identify a reflexive side. So now I've got a side. JL is congruent to JL. And that's reflexive. Or that's a 2, sorry. So now I've got a pair of angles and a side. I've got the A and I've got the S. I need another angle. And there's one more piece of information that they gave me I haven't used, which is that JL bisects KLM. So if JL bisects KLM, that means it cuts it into 2 congruent parts. So 3 angle K L J is congruent to angle M L J, and the reason is the definition of an angle bisector. And now I have enough information to go to step 4, which is that the triangles are congruent based on angle, angle, side. So the last acronym or shortcut is hypotenuse leg. And a hypotenuse only comes on a right triangle. Okay, so they have to be right triangles. That's the first thing. The hypotenuse has to be marked as congruent. The hypotenuse is the side opposite the right angle, or the longest side of your triangle. And then one of the other pairs of legs has to be marked as congruent. So if you look at this, is just identifying the parts. Make sure you would be able to look at a right triangle and identify which one's the hypotenuse, which again is opposite the right angle. And then either of the other 2 are legs. Due to the last one. Hypotenuse leg, or HL. So it's the only one with 3 letters because we already know something about it. If it is hypotenuse leg, it means it's a right triangle, so you already have an angle in common. That's why you only need 2 letters. Okay? You already know there's a right angle. Now you're also saying the hypotenuse, which the side opposites are congruent, and one of the pairs of legs are congruent. So from the diagram that's there, obviously you should see the right angle. If you don't have a right angle, you don't have a hypotenuse leg. And you have to have the hypotenuse, which is the side opposite the right angle. And then either pair of legs. So in this case, I had BC marked as congruent to FE. You could have also instead had BA and DE. It doesn't matter which pair as long as you have 1 pair.
So if the hypotenuse is marked but the other 2 aren't?
Then it's no.
Okay.
Yep, you need both. And if both legs were marked, you could do, and the hypotenuse, you could do side, 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 hypotenuse leg, and side angle side, right?
You have the hypotenuse on the leg, what if there's
A different angle. Then if it's the included angle, then it works. It's a non-included angle now. All right, so this one just says, determine if you can use hypotenuse leg to prove the triangles are congruent. If not, tell what else you need to know. So look at A. Do you know that those are right triangles? Yes. You see the little right angle. Those tell me that those are right triangles, right?
Yeah, but one of them, right? Not the other.
But if it's two lines, they're supplementary. One's 90, the other one has to be 90,
Aren't
right?
they reflexive too?
The side is reflexive,
Yeah.
so I have a leg. Yes, right? I have that leg. And are the hypotenuses marked as congruent? Yes. So this is yes. And that would be HL. How about B? So these are the two triangles we're talking about. Are they right triangles? Yes. Are the hypotenuses marked as congruent? No. Do you have a leg marked as congruent? Yes. So it's no, and the reason is you're missing the congruent hypotenuses. So the hypotenuse and the leg has to be marked as congruent. All right, last one. Determine if you can use hypotenuse leg. Are they right triangles? Yes. Is the hypotenuse marked as congruent? Yes. Is there a leg marked as congruent? It's not marked as congruent, but what do I know? It's reflexive. So this is also a yes.